Hey everybody, Joe here. Welcome to the shop. And I've got a little project today that is going to be of interest to some people with lathes similar to mine. I've had this lathe for a long time, maybe 20 years. And I've modified some things on it. You know, you've seen my videos, you've seen some of the things I've done to it. But one thing that's always bugged me about this thing is that it has a threaded chuck on it, which pretty much makes all but the basic kind of operations in reverse dangerous. You know, you run that thing in reverse and take too heavy of a cut and that chuck unscrews. Now, I've never had it happen to me. As far as my VFD, the way I've got it set up, I have heavy forward acceleration, so you know I can do that because it'll just tighten the chuck. But in reverse acceleration or forward deceleration, I have turned those numbers way down, so you know the inertia of the chuck and whatever else I'm turning on here doesn't, you know, loosen the chuck up. But I'm going to basically do something here. I'm not going to really modify anything on the lathe, as you will see, but I've come up with a way to connect this chuck to the spindle and make it impossible to come off. So I'll bring you in close and I'll show you what we're going to do here. Okay, so here we are looking from the tailstock into the hole in my chuck. And you can see right, this first little line here is the intersection between the back of the chuck and the front of the backing plate. Right now, there's a gap of about 5 thousandths. The way I turn this chuck backing plate is there's a register that's turned on it and a raised center section that fits into that register. So anyways, the plan is you can see, I've got plenty of meat in here. This inner ring here that you see, like you can see it shining in the back, that's the end of the spindle. So there's probably a good 3/4 of an inch of cast iron before the front of the spindle. Now what I'm going to do is I'm going to take a piece of my alloy steel right here and I'm going to turn a big ring, essentially a washer with a hole in it that's about 200 thousandths less of a diameter. So what it'll do is it will create a raised section inside of the bore that will allow me to put a draw tube in here and butt up against that. And when I tighten it on the back end of the spindle, that will lock the chuck onto the spindle. So the only thing I really have to modify here is the backing plate for this chuck. And you know, the result of this modification will be that I will lose some of my through-hole bore, but I can take that thing out of there in 2 seconds because I can take it out through the front of the chuck. And yeah, then I will have, you know, a little ring in there, you know, that's sticking out maybe 100 thousandths. But I don't know if I can show you this. I don't know if you can see this, but way down inside, probably about 6 inches down, you can see that the spindle diameter necks down. So I really won't be losing anything because that's the minimum diameter way back there. I don't know why they made it a little bigger up here, but they did. So my ring will sit proud, basically the same amount that shiny ring back there is sitting proud. so I won't lose much. And if I have to, I can take it out. Now, as far as the ring goes, yeah, I can make it out of this piece of alloy I got up here. That's 4140 pre-hardened. And I think it's big enough diameter to do the job. As far as the actual drawbar, you know, I really would love to be able to use my collet chuck drawbar. Where is that thing? This thing right here. But you know, it's a nice hunk of machine precision steel, but it's got a right-handed thread on it, so I can't use it. The whole concept of this thing is that it has a left-handed thread on it, so that it locks against that ring and won't ever unscrew. I think for a prototype kind of a thing, I have this piece right here. Now this is just regular welded steel mechanical tubing. There's nothing precise about it. Eventually, what I'll probably end up doing is, you know, something like this. You know, I'll end up buying a piece of steel. I was looking at Speedy Metals or Online Metals, one of them, and it's like $10 a foot for what I need. So I just get that, and it's DOM stuff, so it won't have a weld seam on it or anything. But I think just, you know, as a proof of concept, you know, this piece right here is probably going to be the one we use. And hopefully it's straight enough that it'll do the job there. So yeah, the first thing what I'm going to do here is I'm going to take a piece of that and I'm going to chuck it up, and I'm going to you know, make basically what amounts to a thick washer. And then after that, what I'll do is I'll take this chuck off of here and I'll machine the back plate, a recess in the back plate for that washer, and then we can put this back together again because we're done with that, and then we'll start making this. And you know, we'll have to do a left-handed thread on the end, and then we'll have to make a left-handed you know, nut, like this kind of nut, spanner nut. And you know, it'll just, you know, basically butt up against the end of this, that nut, and just lock the whole chuck on there. And then you know, I probably won't modify any of my VFD parameters to make it excel or decel any better, but I'll be able to turn, you know, like the way Joe Pye does, turn internal threads going away from the chuck. So, you know, I mean, that right there makes it all worth it. And yeah, I'll lose a little on the bore, but I think it's worth it. I think it, and you know, like I said, it's not modifying anything, so if you want to put it back, you can. Just, you know, you got to take the chuck off, but yeah. So stick with me here, and we're going to start cutting some metal. Okay, so as luck would have it, I have a piece here that's, I'm going to be able to get a washer out of the back of this. This is why you save your mistakes. Originally, this was supposed to be the beginnings of a collet chuck, you know, that threads on the spindle to my lathe, which is 8 TPI thread. And after a couple passes, I kind of figured out something was wrong here, and it turns out this is a 16 TPI thread. I had set the lathe up wrong, and I didn't measure it before I started cutting the thread. So I learned a hard lesson that you use your thread gauge when you make a scratch pass. And you know. Alright, let's face this off. Okay, I guess what I'll do now is bore it out to the same diameter as the spindle minus 200 thou. So I have 100 thou lip on each side of it. Okay, so what I've been doing here is just measuring this whole diameter and confirming it. Now this is why I tend to save catalogs. This is an Enco 2005, and where is it? Come on. I can't read this through the viewfinder. Anyway, this is it right here. 1.654 inches on the through hole dimension. Look at them prices back then. 484 bucks for that 6-jaw bison chuck. And I'll tell you, now they're going for like $1,000. This is the best thing I ever bought for this lathe. I love this chuck. If I had to do it over again, I'd get an 8-inch. This is a 6-inch. But, yeah, I like this chuck. So anyways, now that we've got this, and yeah, it did match up pretty good. I will be able to cut that hole, bore that hole diameter out. So let me throw the chuck back together and we'll get to drilling and boring here. Okay, so this is the idea of the chuck right here, 1.654, and what we want to do is we want to have 100 thou lip on each side, so we want to subtract 200 thou from that. That works out to 1.450. So what I'm going to do, just for rough measurements here, set that to 1.45. Okay, and then I'm going to zero it. And now, what this tells me is I have 192 thou to come out of that. So we'll start cutting here and measuring, and when we get close, we'll start using the Uzi what's this here. feeding this because it's such a short distance. I think I need another link in my lock line here. Alright, so that should have been 100 thou, which means I would have 97,000 more to go. Okay, 85 thou. 42, so... Okay, 45 thou it says. So we'll take another 20. That should get us pretty close. Alright, we're right there. Yep, that is it. Okay, so we'll do a little deburn here and part this off, and that'll be our ring. Now right now this depth right here, I can't get in there, but I measured it with my depthy thing here, and it was about 200 thou. You know, this is alloy steel. I'm thinking I'll probably, you know, I don't want to cut back on the back plate too much, so I'm thinking I might want to make this about 150 thou. Okay, sounds like a plan. All right, get set up for parting off here. Alright, time to part it off. Well, that was a lot of parting off. It was long and tedious. So now we've got the ring, and you can see I had to stop to sharpen the tool, and when I got back to it I didn't quite get it in the right place. So I'm going to see what happens here now. Taking really careful cuts here. This thing is really just held in by the very end of the tips of the jaws. So we'll be extra careful here. We'll put a little go juice on there. Yeah, it's not the best finish in the world, but it'll do for what we need. Let's see if I can hit this on the OD here. Alright, get the ID here, and then this piece is done. Alright, that's looking good. Just slap a little Scotch-Brite action on this thing, and let's see how we do here. Alright, so the next thing we're going to do is we're going to take that chuck apart, and we're going to fit this into the face of that chuck so that we get a nice little lip for our drawbar.